Hello, everyone. Welcome back. My God, I took a longer break, but it's fine. We are here now. There is this post article that I want to read. Why is Gin a very bad software library? I don't want to use it if it's bad, if it's that bad. Right. Since we have this, we have it here. And let's see why is it bad. Why is and we'll probably decide whether to change it or not. Okay, let's go. So, in my experience, Go is the best general purpose programming language for backend developer. General purpose, I mean, I don't have a lot of experience, but working with Go a little bit, I can agree. I love Go. And a huge part of this comes from the thoughtful design of its standard libraries. True. They're very lightweight, they're very good. They do what they're supposed to do, and not too much. Not too much around. It's just like if it needs to do something about the JSON, it will do something about the JSON. It won't do something about, I don't know. Yeah, let's go. If you are willing to be a little bit patient, read the documentation, and spend some time getting familiar with their items, you have everything you need without needing to go far afield. True. Most programmers are not willing to be a little bit patient. Also true. They Google Go Web Framework and then they pick the first web result. More than likely, this is Gin, a kind of insidious fungus masquerading as a software library. True. I don't know how I decided to go for Gin. I think I did Google, and I think this one was the most popular one, and that is the only reason I went for it, because my first project I did in Go, I did without any libraries, right? Look at this. There's nothing here. Of course, there is for WebSockets, GRT, yeah, sure, crypto, and we have Temple. I wanted to use Temple with HTMX, but there is no frameworks for Go, because I've written all the APIs by hand using only Go, nothing else. And it felt great, but I wanted to get familiar with one framework at least. So it's mostly for future potential jobs. If I ever get employed somewhere, they use Go, they use a web framework. Let's know about it, right? Let's not go completely blind. But in eventual rewrite of this application, I will remove. First thing I will remove is web framework from Go. Yeah, 100%. Okay, let's go. Moving on. Like many fungi. Oh my god, I like. For some reason, I like that word. Simply because you would never expect to be pronounced like that, right? Especially in my language, it would probably be something like fungi, fungi, fungi. No. Okay. It is easy to pick up Gin and almost impossible to remove it. Unless you're extremely careful, you'll pass it on to your friends. Okay. The features that make it inimical. I'm sorry, what? Inimical. Tending to obstruct or harm, unfriendly, hostile. Inimical. Damn. Okay. Gotta remember that one. Inimical. To human life are directly related to its success. cool. And it will likely outlive you and me despite everything we do to eradicate it. Yeah, fun guy. Yeah. You can learn to live with it, but you shouldn't have to. True. Gin is not the only bad library. Yeah, I mean, we are developers. We are bound to create something that sucks. Hey, isn't that the biggest of truths? Like, if you are a developer, there will be something that's sucky. And you have to get past to it. You have to get past through it and get to the other side where you actually know something about the stuff you're creating, and it sucks less and less until it doesn't suck at all. In fact, Gin is not the only bad library. In fact, it's not nearly the worst library in common usage, but it is the library that pisses me off the most day to day. And I think it's emblematic of many of the biggest flaws of software library design writ large. Design writ large. Library design writ large. Okay. Yeah. 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 So I did I did a bit of pre-reading, maybe half of the article. That's why that's when I decided to read it on stream as well. And it's the same problem as most of the JavaScript. We'll see. You'll see. We'll all see. Okay. Before we begin, this article is mostly a rant, for which I apologize in advance. It's all good, don't worry about it. Gin is a very old library as far as Go goes, and is based off an even older one, Go Martini. Okay, we went from Martini to Gin, nice. Maybe whiskey later. Many of its first mistakes are artifacts of that time, and some things that appear to be mistakes are an artifact of predating that functionality in the standard library. Okay. Okay. I'm confused here. I mean, I'm confused for the developers of Gin because I understand that you can carry on a lot of bad technical debt from before, especially when it's library to library, right? But why not try to overwrite something that's. Maybe they don't consider it bad. You never know. I shouldn't have to say this, but you're not a bad person if you use it, of course. I mean, you shouldn't have to say this. Come on, man. Come on, people. Have used or work on Gin. Please do not use these sermons as a way to brigade people for using unfashionable code. People make sort of decision based off cloud is part of how we got into this mess. Yeah, sure. Update. I'm not trying to imply that you should never use libraries for backend developer or that using something besides net HTTP is somehow wrong. I have happily used libraries like Gorilla Mux and its associated friend, and I see nothing wrong with it. For example, Chi, I'm using the standard library as a comparison because it's what I use. A very good library, not perfect, but very good. Yeah, it's very good. A dependency every Go program has by definition. True. I am saying that Gin is a bad library and that you should be suspicious of libraries that share its flaws. We'll get into the flaws, but oh no, wait. I didn't want to do that. I wanted to do this. Yeah. We should. I will probably go with G. It's lightweight, yeah, fast, compatible, yeah. In production at Cloudflare. Okay, that's not the flex. I'm kidding. But yeah, this is what I'm talking about, right? Like, look at these big uh, companies, and they all go for frameworks. So why not get familiar with one, right? Doc generation. Oh, really? Huh, interesting. Maybe I don't need Swagger. Maybe I don't need Swagger. We'll see. Go mode support, no external dependencies. Okay, cool. Okay, well, wait, let me get back to the library. I mean, article. Mm. Okay, let's go. Comparison of basic service in net HTTP and GIN. Okay, let's get to it. On a surface level, basic HTTP work doesn't look too different in net HTTP and GIN. Yeah, okay. So here we create a new server, we have a handle function, we give it something, we respond with message. Okay, the message is pong. Pong. Yeah, we have the writer, we have the request. Okay, pretty standard. We serve it on this port and listen on it. Okay. I mean, we create a server here, yeah, and we listen on it. Yeah, we create a server and then we listen on it. Yeah. Okay, basic server gin. Wait, did I? Surely I have one as well. No? What is this sort? Okay, that's it. Yeah, we have the default, and then we have here we have get source file any, and we have test. Okay, yep. Yeah, get ping, and we get the message. We send the message with JSON. Yeah, we created a test response and we send the response with JSON. Yeah. Okay. On a surface impression, Gin might seem easier, it's slightly fewer lines of code, and there seems to be less configuration. But this is all surface. Yep. The proper way to judge a map is by the terrain it covers. In other words, before you choose any software, first you should know the problem you're trying to solve with it. So before we pick on Gin, let's review the terrain. HTTP. HTTP is not that complicated, a brief review. Okay. Happily, HTTP is not that complicated, and we can go over the basics in about 90 seconds and a handful of chalk drawings. True. The hypertext transport protocol has a client send HTTP request, yep, and a server response with a response. Cool. A client sends a request to a server, the server parses the request, figures out what the client wants, and sends back a HTTP response. Yep. I mean, yeah. If you want more details on the structure, marking backend from the beginning, builds an entire HTTP library from scratch and goes over all parts of these details. Yep. I mean, it's simple. You got the request line, you have the headers, you have the body. Then the possible trailers. I mean, it's not that hard. Yeah, you can see it here. So request line, method path version. Yep. You have the headers, host, authentication headers, content length, etc., etc. And then you have the body. The body, right? If you are doing a post request or a patch request or a put request, and the front end, or well, whatever is making the request, it can be curl, right? Sends the body of what to do, and then you figure it out. Client sends request, parsed by the HTTP library, yeah, and then we have the response, which is on, okay, status line, so we have the code, right, status okay, cool. We got the headers, they're usually the same as in the request. You can add more, I guess, but yeah, front doesn't frontend doesn't usually handles yeah, sorry. Wait, what was I saying? Yeah, frontend doesn't usually deals with headers. We can send the authentication, but I guess it's better to send it with cookies. Since you send every cookie, okay, not every cookie, but basically every cookie you send during every request, and then you can, yeah, parse the token, etc., etc. Okay, let's move on. I got distracted. HTTP requests have four main parts separated by new lines. Yep. A request line specifies the HTTP method, get, post, etc. Yep. The path being requested. Yes. So we have the get. That's the method. We have the path here and the HTTP version. Usually you don't really handle this. Well, you do because you have to know how to handle it. But yeah. One or more headers that provide metadata about the request. Yeah. A blank line. Yeah. To separate the headers from the body. And an optional body that contains data being sent to the servers. Usually just so. Yeah. They look like this. Yeah, we have the method, we have the path, and we have the version, and the headers, empty line, body. Yep, cool. HTTP request, yeah, request line, headers, extra headers, and then the body. Okay. Responses have a similar structure with four main parts separated by new lines. What do you mean four? I mean fourth, yeah, it's trailers. So after the body, there's an empty line, and then there are trailers. This is the fourth one. Status line, yeah, the version of the HTTP and the status with the code and the text. Okay, moving on. A couple of structural notes about HTTP. These parts are ordered. You can change your mind. Yeah, you cannot. Gotta be ordered. Once you've sent the body, you usually can't send any more headers. Yeah, you can send trailers. They're basically headers. They just come after the body. You don't have to send the whole body at once on either side. You can stream it. Yeah, and this is when this is where you need trailers. Usually, you can send like how much of the body is left to stream it, right? Something like that. Fundamentally, the structure of our solution, the HTTP library, should mirror the structure of the problem if the solution is. Wait. Fundamentally, the structure of our solution, the HTTP library, so Gin, should mirror the structure of the problem if the solution is. Okay, so there's missing some punctuation here. Come on, man. The HTTP library should mirror the structure of the problem. Full stop. If the solution is significantly larger than the problem, one or more of the following is true. What following? Gene is significantly larger than the problem domain. Okay. Yeah, but what is true? I'm confused. Okay, moving on. It's fine. Don't worry about it. Just don't worry about it. Gin is significantly larger than the problem domain. Yeah. The Go library, net-HTTP, covers all of the HTTP 35 files of pure Go and 25,597 lines of code. Not a lot of code, including the server, client, TLS, proxies, etc. Cool. Gin and its dependency chain covers only server-side handling and requires only server-side handling. 2,000, what the fuck, and a million lines of code, including 80,000 lines of platform-specific GNU-style assembly. Okay. What are we doing here? What are we doing here, man? Come on, man. Why we like that? Why we like that? Man, I love this music. Okay. Why are we like this? What? This is nuts. Yep, you can crack an egg with a artillery shell. This does not make it a good idea. No, it doesn't. No, it doesn't. Don't do it, kids. Don't you fire a 155mm artillery shell to crack an egg? Don't you do it? This does not make it a good idea, even if you add rocket boosters and laser guidance. Yep. Minimal interfaces. Some people would argue that the code weight doesn't matter. Yeah, it does. Everything matters. I swear, everything matters in coding. It's crazy, but it's true. Some people would argue that the code weight doesn't matter. What we should be worried about is the API. You should be worried about the API, but code weight is a bitch. I.e. the interface we have to keep in our heads. Yeah. They'd probably sneak in a quote about premature optimization or something. No problem. So, premature optimization. I mean, you have to do everything in the best way possible. Like, sometimes you don't really know how much of the something stuff will be used, or sometimes you don't have the full information, and then it's fine to skip on something, I guess. But in any case, you should strive for the best performance, for the best code. Don't be lazy, people. Don't be lazy, people. The following diagrams illustrate the minimal APIs to understand native HTTP engine. Okay, so this is for net HTTP. Okay, we have so these are the structs, the methods, and the interfaces. Okay, so we have what is this then? It's nothing, I guess. It's not a method, it's not a struct. Okay, so this is the interface, and we have a couple of methods inside. We handle the function, we make the server, all good. We have the request interface, and we have inside the request body also an interface. And we have the JSON or Marshall or struct, right? Implements the IO reader. This one implements the handler. We have the writer. We write the head, we write the body, and we have the Marshall here, also a struct. It implements IO writer. Pretty simple, right? The request comes, the request gets handled, the response is written, the response is sent. Easy. Okay, Well, this is for the gin. Do I even dare? Do I even dare reading this? Like, what the fuck are you doing? Man, man, what are you doing? I know. As hard as it is to believe this graph omits a ton of details. Yeah, I can imagine. This is not all, by the way. Okay, okay. Crazy talk, crazy talk. Choosing gin. Human beings are bad at making judgments. Human beings are bad at making judgments. Period. Especially about things they consider boring. True. Yeah, very true. If you're reading this, you're probably a programmer. Yeah, I am. Take a moment to think about how the dependencies were chosen for the current project. Ask yourself, or better yet, a teammate, the following questions about your major dependencies. What are your major? Okay, so let's not go for this one. Actually, let's go for this one. Let's go for this one. Let's see. What did we choose? What did we choose? What? Mm. Okay, we have chosen a lot. You know, it's crazy that all of this. Okay, these are not the major ones. These are the major ones, right? Here. Yeah, so we have the gin. Why was gin chosen? Well, well, I was looking for the most popular framework and I saw gin. I saw a couple others. What was it? Was it Echo? It was Echo? No, maybe I use Echo instead of G. Echo Go framework. Yeah. Maybe I use Echo. We'll see. And what else do we do? We have Swagger. I mean, Swagger is pretty much self-explanatory, and we'll have a bit more. We'll have a bit more. Same way I have it here. We have UID. We'll need this for the users. Go to this is for the environment file, so we can load everything in. And PQ, this is for the PostgreSQL, but I'm planning to use SQLite for this project because again I want to get familiar with it. I already used PostgreSQL here, so I'm not going to repeat myself. And then we have crypto for some encryption. We have GFT also for encryption. I mean, for creating GFT token. And we have the Gorilla WebSocket, which is the best WebSocket library for sure. And for the on the same one for the front end, it's here. We are using Temple and HTMX. You can see it here. HTMX and Temple creating templates, which gets converted into this. Yeah. And the current project for the front end, we are using obviously a great React. Like here, 19.2. I did not. I did. I did track what they say about the newest the issues with React. Security issues, right? Yeah, we all know about that. I didn't. I didn't check. Was my version impacted as well? Not 100% sure. We'll see. We'll see. Yeah, and in React we have IIT Next. It's great for translations. We have anti-the, which is, I mean, it's anti-the. Come on. And we have the React query, React router, basically from StanStack. They're also kind of necessary, not really. I can write everything from scratch, but still, I want to have something. I want to get familiar with all of these libraries because majority of companies don't write everything from scratch. They use external libraries. And Tanstang is really good. It's proven to be good. So yeah, why not use it? Antido is similar, like whether it be Antido or Material UI or something like that, it's still used widely. And I'm using it as well. Okay. I'm not completely lost about it. Who chose to add them to the project? Why? When? Did they write those decisions down anywhere? No. If so, did they ever go back to re-evaluate those decisions? How many options did they evaluate? What was the evaluation process? Was one of those options write it ourselves? If so, why didn't you do it? If not, why didn't you consider it? All fair questions. All fair questions. Whenever you start a project, you should ask yourself these questions, and you should have a definitive answer for it. Even if it's something like, I want to try it to get familiar with it. Because my ultimate goal is for all of these dependencies, well, except for translations, maybe even for them. Why not? We can just load, it's just loading JSON file, finding the right object and replacing it with it, right? Based on the language. That's all there is to it. Well, only React, not even React. I do plan in the long run to replace that as well. Yeah, basically I want to replace all of these dependencies and create everything from scratch myself. Even the frameworks, even the compilers. The compiler is going to be in Go. Yeah, if we get there. What are the perceived strengths and weaknesses in the following categories? Familiarity, performance, AP surface, documentation, test coverage, code bloat within the package, within its dependency tree. React is not very good with this. Security, React is not very good with this. Did someone write it? Did you read the code? Can you read the code? Does it rely on, say, opaque binaries or platform-specific assembly? Are more features better or worse? Why? Is this always the same? How hard will it be to switch if the decision is wrong? This final point is Jean's curse. It is incredibly difficult to remove, and I think the root of its success. We'll come back to it in our final section. Interesting. I'm not really sure what it makes. What does it make so hard to remove? Right. Because this is like just right. What was it? A handle func, and then we have let's say get and test, and here we have we have the function. We have the function like this, and then we handle it here, right? And this is basically the same. we have the writer, and we can write header, let's say status OK, and then we can write I don't know, whatever, right? Some JSON, and this is basically the same like this, and I'm not sure why. Actually, I know why. Because of this. Here, everything is in the Gin context, where you have JSON, you probably have HTML, HMX, HML, and so on. No, XML. What am I saying, man? XML. That's probably the biggest reason why it's hard to remove. Because then you have to rewrite everything. That's my guess. I'm not really sure because I never used it, but that's my guess. Yep. For the vast majority of projects, there is no answer to these questions because no one ever thought about it. They went into Google search or ChatGPT, typed best colon web framework Reddit, and called it a day. True. I know this because I have seen it happen at least 20 times at half a dozen software houses. While understandable, software is a busy, stressful job, this is not acceptable. Agreed. This is the kind of reason you apply to choosing lunch, not even lunch, not critical software dependencies for million or billion-dollar projects. Yeah, I agree. We need to put more thought into everything we do. And I do mean everything, like even lunch. Like at least ask yourself, is this good for me today? Right. We need to put more thought into even basic things and everything we do, especially something as important as creating your project, writing software, choosing a library, choosing even that structures you're going to use in your project. Everything is you should um, think about it. Okay, let's go. Moving on. Gin is too big. Gin is too big. Code and binary bloat. 1 second. Yeah, in anything at all, perfection is finally attained not when there is no longer anything to add, but when there is no longer anything to take away. Oh my god, it's so beautiful. That is so beautiful. Huh, interesting. Gin is too big. Gin is enormously, staggeringly big. Its dependency tree is over 55 megabytes. If you're just taking the lines of code in Gin and its dependencies. Is this megabytes? Why is it MIB? What? Never seen MIB. Maybe bytes. It's slightly larger than 55 megabytes. $57, yeah. Representing 55 times? What? It's common way to measure, right? I know it's converter. I don't need this. Interesting. Damn. Okay. I didn't know this existed. What the? Okay, this just goes to show you that even as a programmer, I don't know a lot of things. There's a lot of things to know. There's so much to know. If you're just talking the lines of code in Gin and its dependencies, ignoring comments and documentation, we have a lot of fucking lines, man. Almost 900,000. Look at this. Look at this. This is a huge, enormous elephantine. Elephantine cost must be paid by every single project on every single Git clone or Git or Go build, and some of that cost leaks into the compiled binary too. Yeah, yeah, yeah. Gin contains, I kid you not, at least 6 different JSON libraries, not counting the one built into the standard library. Okay. Okay. Why is this? 13, 3, 12. You pass. Okay. Then. Table comparison of Gin and other frameworks, programs, libraries, etc. The following table compares the code bloat of Gin to other popular and or historical important programs or written material. Okay. Okay, library, Gin. Files, a lot of files, a lot of code lines. Okay, this is, I guess, the test coverage. No? Okay. We have G, 85. Yeah, do we have echo here? Yeah, we do. Labstack echo. Echo is still massive. Okay, we are not doing echo. Oh, it's so big. No. We are not going echo. Okay, we might go G. Seems the best. A complete operating system. What the fuck? Quake. Okay, Quake. It's smaller than fucking than Echo. Not even talking about Jin. Okay. Okay. Wait, this is a whole language? Oh my god. Wait, there's no way. Systems, programming language, and tooling. Wow. Okay. The Bible King version. The Bible King James version. Okay. Okay. Nice. Cool. Damn. This is, to be blunt, completely unacceptable. If you pick the same framework like G, you don't need a framework. Yeah, you don't need a framework. You don't need. It's so easy to write everything pure Go. But for the sake of argument, you could bundle in DOM a C compiler to build with it, a C compiler to build it with. Okay. Let's pick Zig and an operating system to run it on, like MS-DOS 4.0, and throw in a Varo piece and the entire King James Bible for good measure, and you'll still have less bloat than Gin and its source tree. Imagine. Doom, Zig, operating system, and War and Peace and Bible. And still less bloat. Unbelievable. While Go's compiler is pretty good about eliminating unused code, Gin does its best to touch as many different libraries as it can import at time, so the compiler can do that. Okay. At import time. Okay. Not even at the compile time. Damn. To demonstrate, let's strip down our examples even further and build the simplest possible Gin programs and an equivalent HTTP service and see how big the resulting binaries are. Okay. Yeah, pretty simple. Like what you write header here, any. There's any. Why is there any? Don't do any, kids. Don't do any. What? There's any? Okay. Okay. It's like the biggest reason not to use gin. Any. What the fuck? And yeah, this is in the. Oh yeah, this is basically any, no? You get this handler on every single. Yeah. Wait, but isn't this like any method? And this is basically only on get. And this is any method. I'm still confused about it. Okay, let's not think too hard about it. Moving on. Let's examine the compiled output. Simple gin. Yeah. Yeah. Like what, 2.5 times more? Yeah. Maybe it's just debug symbols. Let's strip the binaries and try again. Okay. Strip. Test again. Okay. Now it's almost 3 times more. Where's all this bloat coming from? After a while, we don't use most of Jin's features. Okay, let's use go debug init trace 1 to see what packages are being initialized, to see if we can figure out where all this bloat is coming from. Okay, many lights omitted, yeah. There's a lot of noise here, so I'll summarize a couple of highlights. Okay, you pay for Tom, Gob, Yam, Protofab, HML, and at least 2 JSON libraries regardless of whether you use them. Wow, okay. You pay for HTTP3 quick, even if you are not using it. Okay. This cost is a direct result of Jin's horrific everything in the kitchen sink API. More about that in a bit. Damn. Okay. Side note, as it turns out, the Jin team has been trying to deal with this enormous binary bloat. You can eliminate the dependencies on message pack by adding the build tag no message pack, which shaves 10 megabytes of dependency. This should be the default. Yeah, it should be the default. No tags, no nothing, just do it as a default. Okay, I guess. Jin's API has a surface area of an industrial heatsink and sucks nearly as much. Increasingly, people seem to misinterpret complexity as sophistication. No. Which is baffling, yeah. I don't know why. The incomprehensible should cause suspicion rather than admiration. Yep. The simpler it is, the better it is. It takes a smart man to put something simple. It takes a smart man to explain something complicated in a simple terms, right? It's kind of same for the programming because you're basically explaining to the computer what it needs to do. I mean, computer. I say computer, but it can be from the little motherboard to everything, right? To a website. And in that explanation, the simpler it is, the better it is, the more of a genius you are, right? I mean, let's not go that far because you can learn it. You can learn to be simple. Just practice it, find it. And that is basically the goal of this project. I want to become a programmer that's looking for a simple way, easy way. Let's not bloat our code. Let's not add unnecessary things. Just make it simple and make it do its job well. Okay, a quick note on Unix before we dive into Jin's API. Unix is one of the oldest traditions in software still standing. Yep. In this tradition, good APIs have a small surface that exposes deep functionality. The classic example in Unix file system API, which made it a long way with only 6 verbs: open, close, read, write, seek, and FCTNL. FCTNL. This is enough to handle disk drives, shared networks, file system, terminals, printers, etc. There's a good argument to be made that this is not the correct file system API anymore. FCTNL is clearly cheating, okay? And it doesn't handle node blocking or concurrent I/O that well. This is the excellent talk. What unit costs us? Maybe check this out. Okay. Go is firmly part of this tradition. Yeah, it is. It's not bloated at all. It's so simple. And as such, standard libraries tries to minimize the API surface where possible. The vast majority of interfaces in Go standard library have 3 or fewer methods, usually just one. Even the largest interface in Go, net.con, handle connections, tops out at 8 methods. Jin does not do this. Yeah. Reflect that type does not count. It's never meant to be implemented by external libraries. All its implementation are internal code gen. Yeah, and reflection is always kind of an exception to the rule. Please don't add me. Okay, let's not add him. Do not add him, boys. Let's take a look at how NetHTTP is designed to see this philosophy in action. It's a beautiful API. Yep, it is. Server-side HTTP in Go can be summarized in 4 types and 1 sentence. The HTTP server parses packets into HTTP request track, hands them to the HTTP handler, which writes a response via HTTP response writer. So simple. There's nothing complicated about it. Maybe if you've never written one before, maybe it's complicated a bit, but it's right. Usually that handler is some kind of router like HTTP server max, that dispatches different some handlers, but it doesn't have to be. Yeah. You know, while we're at it, I have no idea what I used. What did I use for my thingy? Matches, config, matches, http.handle. I don't have a router. Damn. Okay. Ballsy. What do we do here? Yeah, we have all the handlers here. And just handle function. Yeah, we have the method, we have the path. We join them. And we add the handle function. Cool. Okay. To give a quick example, here's a minimal HTTP server using only the Go standard library that responds to PostGrid while we use okay. While we use a number of types here, there's only a handful of interfaces. We need to understand this code. HTTP handler, HTTP response writer, and the omnipresent IO reader and IO writer interfaces used by JSON encoder and decoder. Okay, let's see. We have the writer, response writer, which has the write header, the status, write, the bytes. This can be JSON, this can be HTML, this can be whatever, right? I mean, before the conversion, it can be anything, yeah. And we have the headers. I think we can add headers here. We have the reader should read, true, and the writer should write, true. And the handler serve HTTP, yeah, that's the with the response writer. Okay, we already saw this. Okay, we go to the gin. Oh my god, I can already see the bloat. You can see it. It's right there. Oh my god. To summarize Gin's API in a similar way, the Gin engine gets HTTP requests, routes them using its embedded Gin router group, and turns them into a Gin context, which contains a HTTP request and a Gin response writer, and hands them to one or more Gin handler functions, which modify the Gin context. Okay. Wait. So Gin engine gets the request. Okay, then routes them using the router group, okay, turns them into a Gin context, which is a pointer, which contains a request, yeah, and a response writer. It's a Gin response writer, by the way. It's not a HTTP Gin response writer, even though it's HTTP request pointer here, right? It's a Gin response writer. And has them to one or more Gin handler functions, yeah, which modify the Gin context. Yeah. So it's right here. You get the Gin context and you, I don't know, send the JSON to it. Simple enough, but yeah, this doesn't sound too bad. It doesn't. It really doesn't, because it's simple. It's simple. We have the method. We have we pass it the handler, and it's simple. It's simple, but it's never that simple. It's never that simple. In fact, it sounds almost the same. Let's take a look at the method summaries of these types to see what we're dealing with here, starting with a Gin engine. Nice. What is this? 23? No, 22. We started to. Why do we start to? 22 methods. Okay. Cool. I'm not going to like what load HTML FS file system. Load the HTML files, load HTML glob. Okay, cool. This is a mess. This seems to cover routing and middleware, like we'd expect. Delims, no method, no route, use, routes, server configuration, and HTML templating, yeah. Yeah, it handles everything. By the way, for the 10,000 configuration option here, 10,000 configuration options here, none of them let you select the HTTP server to use. So good luck if you want to do things like set timeouts or do connection or packet level configuration. Gin is hard-coded to use the default HTTP server. I think you can do that by calling the handler and passing that to HTTP server, but I'm not sure, and it's not covered by the documentation. Maybe it's with. Maybe it's in with. I don't know. But that's not all. Like I mentioned earlier, the Gin engine embeds a router group. Okay, that means in addition to the previous, it also exposes the following methods from the router group. We have the any, we have the any, we have the any. Base path, delete, get, head, handle, options, patch, post, put, static, yeah. These methods cover routing. For some reason, they present every HTTP verb as a separate method. Yeah. Yes. And static file serving in 4 different ways. All of these except group, return, and IO routes interface, and nearly all take handler function. Really? Handlers, handle func, handle func, handle func, handle func, handler func. Whoa. This could almost be one singular method. Yeah. Okay. Okay, Gin Heller Funk and Gin Contents. What's a Heller Funk? Finally, a small interface. Maybe this is the equivalent of HTTP response writer. Let's look at the export interface of Gin Context. Okay, we have context, we have writer. Yeah, this is a Gin response writer, not a HTTP response writer. Small typo here. It's fine, don't worry about it. Keys, errors, accepted. Okay. Contains filtered or unexported fields. Okay, so it contains the HTTP request and a GIN response. What's a GIN response writer? It has the response writer for the HTTP, but also has a lot of other things. Okay, that's a, I guess that's a joke. That's a joke. Okay, we don't see the cars. We don't get the cars. The bigger the interface, the bigger the abstraction. Okay, true. Okay, so stopping here. This already contains the entire API surface area of the net HTTP interface. Gin only adds complexity, as well as an extra 5 public fields and 10 methods on those fields. That's not good. But the real horrors are yet to come. Gin contains list of methods. Okay, let's see. 133 functions. What? Oh my god. What are we doing here? What is the difference? Oh my god. Oh my god. 133 functions. Damn. That was a lot of them. Sorry. Okay, this is the nightmare. Yeah, it is. Even a simple Gin server that only receives and sends HTTP with JSON bodies over net HTTP is unavoidably linked to this enormous complexity. Yep. For no reason, basically. Even if you just want to send and receive JSON, there are 11 different ways to do this, as methods on Gin context, all of which behave differently depending on build tags and magically invoke multiple layers of struct validation. And some of which depend on the configuration of your Gin engine, not to mention writer write string and writer write. To pick a single example, where am I? To pick a single example to know the behavior of secure JSON at runtime, I need to know, among other things, which of the 6 JSON libraries was this built with? Am I sure my test environment has the same build tags as deploy? Did the Gin engine that's running this function, one that is not visible in the function signature of handler function, set a Gin secure JSON prefix? Good question, good question. Status headers are even more complex. There are 24 different ways to set a response header via methods of context fields, including context.status, okay, writer.status, writer.write header, reads a previous written status header sometimes. What do you mean sometimes? And this reads on a writer. Okay, I guess. I guess. uh, write status header, but not in a way where you can always retrieve the status header with writer status. Yeah, I have run into this and I'm salty. Okay. My man is salty. As intimidating as these giant list of methods are, it turns out the vast majority of these methods are wrapped around the same core functionality. In fact, they are wrappers around the exact same functionality as net HTTP response writer. Let's follow. Okay, wait. In fact, they are wrappers around the exact same functionality as net HTTP response writer. Let's follow the ordinary JSON down the chain and figure out what's happening. Okay. The JSON method calls the exported function write JSON, which calls crender. This writes status by calling status, which just wraps HTTP response writer write header. Really? Okay. Takes the interface render, which calls the magic method write content type render on the magic exported global variable codec JSON API of type JSON core, which happens to be the conditionally compiled empty struct codec JSON API. Then writes the marshaled bytes to the HTTP response writer. There's a lot of magic happening here. A lot of magic. The magic exported global variable depends on your build tags. Usually this is std libraries encoding JSON. That is, it's, yeah, like, why do you need anything more than this? With a lot of extra steps in between. Yeah, writing the content type header is similarly convoluted. JSON calls render write content type, which does a vtab lookup to find render JSON write content type, which calls the ordinary function write content type, which does a vtab lookup to find header on the response write and then sets the header in the ordinary way. This is the JSON. Okay. This is just the JSON handling. So this is just this. Nothing else. Wow. So complicated. For no apparent reason, right? Like why? Why does it have to be so? Huh. Nothing inside the box labeled gin does anything at all useful. And again, this is just one of the 11 different ways to send JSON responses in gin. Most of them go through similar contortions. All of them have their own structs for some ungodly reason. We haven't even covered requests. Yeah. Oof. I meant to, but this article has taken me multiple full work days already. Yeah, I can imagine. I mean, we've been reading it for like an hour, even more. Whoa. The worst of both worlds. This approach is god awful. Yeah, somehow combining the worst of both runtime lookup, extra indirection and function calls, and conditional compilation. Both you and the compiler have to jump through multiple layers of indirection to figure out what is actually happening at runtime, for no benefit whatsoever. These extra layers serve merely to bloat the binary and confuse the programmer. In the default case, the case for 99.5%. In the default case, the case for 99.5 of Gene's customers, you are doing the exact same thing as a standard library, but splitting the responsibility over half dozen extra interfaces and types and hundreds of lines of code. Yes. Yes. 100% yes. Yeah. Yeah. All I had to do was, so if I have my like HTTP response writer here, I can just like marshal this, right? Like we have this and what was it? Just marshal, and we pass in the response, and we instead of this, what the fuck? Instead of this, we just w.write b, and that's it. Like that's it. Like where is the reason for everything in between? Like why? I'm sure there is they had their reasons. I'm sure, but it's not necessary, as you can see. If you wanted to use a different JSON library, you could just use that library. Okay. All Gin does is cure the control flow in in what? What? In Kukai. In wait, how do inculcate? Inculcate. 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 Okay. Instill. By persist instruction. Okay. Okay. A sense of helplessness in the programmer and causing cache misses at runtime for no benefit whatsoever. True. Small nitpicks about render. Why the hell does render take a HTTP response frame, not just an EO writer? Is it supposed to do something different from writing the body? On a similar note, why does the write content type take a whole HTTP response writer? Is supposed to modify the body? You should take a HTTP header, or maybe be the slightly more sane interface content type string, or better yet, not exist at all. Okay, true. Gene's documentation is very bad. Okay, let's keep this section short. Gene's documentation is sparse at best. An illustrative example is Gene router group. Despite its enormous API, its documentation is limited to a handful of sentences split between Gene router group itself and Gene router group handle. Router group is used internally to configure router. A router group is associated with the prefix and an array of handlers middleware. Okay. Handler registers. Handle registers a new request handle and middleware with a given path method. The last handler should be the real handler. The other ones should be middleware that can and should be shared among different routes. See the example code in GitHub. Note, no link is provided. Okay. For get, pause, put, patch, and delete requests, the respective shortcut function can be used. This function is intended for bulk loading and to allow the usage of less frequently used, not standardized or custom methods. A example for internal communication with a proxy. Interesting. On the other hand, HTTP Server Max documentation is nearly 1,000 words, not counting in documentation examples, split into 5 sections: patterns, precedence, trailing slash, redirection, request sanitizing, and compatibility. I encourage you to click on the 2 above links and take a look for yourself. I will. I'll take a look, but not right now. Okay. No, this is the worst part of Gin. The worst part is this. Going from a HTTP handler to a Gin handler is trivial. You can write an adapter to go from the standard library to Gin in a single line. Okay, yeah. So we have the adapt handler, yeah. We take in the handler, which is we take in a handler, we return a Gin function, which will have the response writer and the request. No, actually, this one returns as well a function. Yeah. Okay. Going from a Gin handler to an ordinary HTTP handler is functionally impossible. Why though? The only practical to do this is to dig into the code, figure out what it's actually trying to do, and rip out all of the indirection. Oh, that's why. So basically, at a certain point, you have no idea what some of these things do in background. Just like how we went through this JSON before, and we saw all the different things it does, which are completely unnecessary. And during development, like you will have like 50, 100 instances of this, and a lot of things can break. A lot of things can break because all of that work in the background. Yeah. If you are still early enough in your software project, this is practical. Yeah. If you're months or years deep into a legacy code base, you don't have a chance. Hell, true. So true. If a single person on your team gets the bright idea to use Gin, you're more or less stuck. You can work around it. But it will be lurking at the bottom of your server, a giant chain of dependencies that you can never get rid of. This, I think, is the secret to Gin's success. It's attractive enough popular enough to attract the trend hoppers and the naive and tolerable. Dude, my ears are itching me this morning. I don't know why. Where we left off? Okay. It's attractive enough and popular enough to attract the trend hoppers and the naive, and tolerable enough for them to stick with it long enough to get stuck. And like restaurants, most people use software because other people are already using it. Worse yet, because it's so difficult and painful to move away, users of Gin make the wrong conclusion that this is because other libraries are hard and they sing the praises of their jailers. Okay. Maybe flies on the web do the same thing. Okay. Conclusion and advice on software dependencies. Gin is a bad software library, and we as developers should stop using things like it. The purpose of this essay is not really to talk about Gin, it's to use it as an illustrated example of what is bad in software libraries rather than good. The choice of what library, if any, to use is an engineering decision, not just a matter of opinion. Yep. It has concrete effects on the process of writing code and the resulting programs. While taste is a part of the decision, it should not be the primary or only one. Gin and libraries like it will make your software worse. Stop using them. I'll finish off with some advice on picking dependencies. Figure out what the problem is before you reach for a solution. Fair enough. The size of a solution should be proportional to the size of the problem. Very good one. Read the code and documentation for yourself. Yes, please. Now, I did miss this one. When picking up Gin, I did not read at all. I just went for the popular web framework. And that is my mistake. There are others. There are other frameworks that I can use. For example, Chi or Chai. I don't think it's Chai. It should be Chi. But yeah, read the code. Read the code. Read the documentation. You can get a lot of it. You can get a lot from it with a simple read, like an hour, maybe two. You can get the feeling for the code. The cost of a library is the cost of a library and its dependencies. Yes, not just the parts you can see. Yep. All things being equal, choose the library with fewer features. Understandable, yeah. Well, depending on the features, maybe those extra features can be useful, but in general sense, yeah, I can agree with this. What if I already use Gin? If you are not in deep, try and rip it out. Yeah, I will. If it's already spread deep into your compass, the best you can do is probably containment. Make a policy to allow non-new Gin. Use ordinary net HTTP handlers instead, where possible, for any future work, even if there's still Gin there. If and when you split off services, force the point of split to leave Gin behind. Whoa, that was a good read. That was a good read. Yeah, basically I agree. I mean, no need to add additional bloat to your project. That, and I really need to get better at choosing libraries. I need to read more documentation and code, even when it's something as simple as the reason to use it is I want to try different frameworks or something like that. Still, read it. It doesn't hurt, right? It doesn't hurt. I can do it on stream. I can do it with someone else. It's all good. It's all good. So yeah, it was a good read, and we will remove it completely. Yeah, obviously. Even the course thing broke because of the interesting. Interesting. It's crazy how it's okay. In the next stream, we'll be removing Jin completely and switching to Chi. I might do this today. I'll probably do this today. I just need a short break now. But yeah, that's good for now. See you boys. See you everyone later.